All right, hello everybody. We are focusing on our last section now of chapter 6. So section 7 has to deal with solving radical equations and inequalities. So how do we solve an equation that has a radical in it? How do we solve an inequality basically that has a radical in it? So here is the easy steps that's already listed off on the left-hand side for you guys. But given this problem, so we're taking the cubic root of some number x, we're subtracting it by 2, and that equals 0. So what can x possibly be? So the first step, it says step 1 is you want to isolate the radical. So make sure the radical is all by itself. So it's not by itself in this case. That minus 2 outside of it needs to go. So I'm just going to move it to the other side. I'm just going to simply add 2 to both sides. Let me get my marker going. Okay, again, I'm going to add 2 to both sides. So step 1, just isolate the radical. So now the radical is isolated equals 2. Okay, so let me drop that down here. We got the cubic root of x is equal to 2. Now step 2. Once you have the radical isolated, you basically want to get rid of the radical now. So it says erase both sides of the equation to the power equal to the index of the radical. So because I have a cubic root basically, to get rid of a cubic root, I have to cube it. So I'm going to raise both sides to the exponent equal to the index. I'm just going to cube both sides. Okay, so again, if I cube a cubic root, these are just inverse operations. They cancel each other out. So what I currently have is I have that x is by itself now, no more radical, and that's equal to 2 cubed, which 2 cubed is going to be 8 as our final solution. Okay, key thing though is you do want to make sure you check your answers. So just because you get a solution doesn't mean it actually works in the problem because we are dealing with radicals here. All right, so if you plug 8 back into the original problem, we originally had the cubic root of x minus 2 equals 0. So I'm going to use a different color. If I plug it back in, we're taking the cubic root of 8, and then I'm subtracting it by 2. That should hopefully equal 0. The cubic root of 8 is 2, and 2 minus 2 is 0, so it all checks out. Okay, so x really can't be anything else besides positive 8. So like I said, because we are dealing with radicals, it says when solving radical equations, the result may be a number that does not satisfy the original equation. If you get a solution that does not work, this number is called an extraneous solution. It's basically a solution that we don't need. So we got an answer, however, it doesn't actually satisfy the original problem. It's an extra solution, extraneous solution. Okay, so again, make sure you check your solutions. We're going to solve each equation, but make sure, add this to the directions, check your solutions. So plug them back in and make sure they actually work in the end. Okay, make sure you check. So looking at the first one, again, step 1, you always want to make sure the radical is isolated before you do anything else. Isolate your radical. So I want to move the 4 on both sides. So now I have the radical isolated. That equals 1, 5 minus 4. Okay, once you have the radical isolated, now get rid of the radical. So it's a square root. To get rid of it, I'm going to square it. So I'm going to square both sides. So when you square both sides of the equation again, these just cancel each other out. I have x minus 1 equals 1. And then solving for x, just add 1 to both sides. That means x equals 2. But now I want to check. So if I plug 2 back into the original problem, so it was 4 plus the square root of 2 minus 1, and all that should equal 5. So first, underneath my radical, I'd have 4 plus the square root of 1 equals 5. The square root of 1 is 1, and 4 plus 1 is 5, so it all checks out. Okay? Moving on to the next one. For number 2, well, the radical is already isolated. There's nothing outside the radical that I have to get rid of. So since the radical is isolated, I can skip over step 1, and I can just move to step 2. So now get rid of the radical. It's a cubic root, so I'm just going to cube both sides. Okay, so that'll handle that. Again, these just cancel each other out. I have 3x minus 4 equals 8 now, 2 cubed. And now we're just solving for x, two-step equation. Add 4 to both sides, so 3x equals 12. Divide both sides by 3, x equals 4. Again, we want to check it now. So plug 4 back into the original problem. So we're taking the cubic root of 3 times 4 minus 4, and this should all equal 2 in the end. So underneath the radical, 3 times 4 is 12. 12 minus 4 is 8. So we're taking the cubic root of 8, and that equals 2, and that is a true statement. All checks out. Okay, next one. First thing, isolate the radical. That 6 in the front has to go. And don't subtract the 6, because 6 is technically, because it's right next to the radical, it's being multiplied by that radical. So to get rid of 6 in this case, again, don't subtract it. Divide both sides by 6, and that'll get rid of it. And now we have the square root. The radical is by itself. The square root of x plus 10 is equal to 7. Okay, so once the radical is isolated again, step 2 is now get rid of the radical. So it's a square root. So you square both sides. So x plus 10 equals 49, 7 squared. And now just subtracting 10, x equals 39. Again, checking your work, plug 39 back into the original problem. So we're saying that 6 times the square root of 39 plus 10 equals 42. Well, 39 plus 10 is 49. Again, this equals 42. So now 6 times the square root of 49, square root of 49 is 7, and 6 times 7 is 42, so it checks out. Okay, moving down to our next example. So they're going to get a little bit tougher here. For number 4, so the radical is isolated. We don't have to do anything there. But now to get rid of it, when you square both sides, since it is a square root, when you square the right-hand side, you're squaring the whole binomial of x plus 3. Which should be an indicator. We should know what to do with that. So the left-hand side is just 2x plus 14, no more square roots. But when you square the binomial again, that means you got to FOIL. You got to expand this out. Write another one next to it. You got to multiply these two together by FOILing. So if you FOIL x plus 3 and x plus 3, you should get x squared plus 6x plus 9, because you'd have x squared, 3x, and 3x makes that 6, and then 3 times 3 is 9. Okay, so as soon as you see an x squared appear, to actually solve it from here now, you should know, again, it's a quadratic, you should know you got a factor. Okay, so bring everything over to one side of the equation. I'm going to move the 2x over here, subtracting 14. Okay, so where are we at? All this stuff cancels. We'd have x squared, that'd be a 4x, 6 minus 2, and 9 minus 14 is negative 5 equals 0. And now we got a factor. Okay, so solving this one by factoring. This would factor, so what multiplies being negative 5 adds to be 4. That'd be positive 5 and negative 1. That's how it factors, so resulting in two answers of negative 5 and positive 1, where we have to check both of them. Okay, so it gets a little bit trickier, like I said, a little bit more complex as we go along here. So if I plug in negative 5, I can already see right now that negative 5 isn't going to work. And here's kind of the dead giveaway. I have the square root, right? So I'm plugging in negative 5 on both sides of the equation. 2 times negative 5 plus 14 equals negative 5 plus 3. This is the giveaway. A square root, if you take the square root of a number, it's not going to be equal to a negative. It's just not. Because this is technically asking for the positive square root. It's asking for the principal root. Okay, and when we talked about that a couple sections ago, when you just see a radical by itself or just a square root by itself, we know we're asking for just the principal root. So it doesn't even really matter what happens on the left-hand side. The right-hand side is a negative number. I already know negative 5 isn't going to work. Okay, so maybe if I check positive 1, hopefully that'll work out. So plugging in 1, you have the square root of 2 times 1 plus 14. And that equals 1 plus 3. Okay, this one should be okay. 2 times 1 is 2. 2 plus 14 is 16. The square root of 16 we're saying is 4. And that's obviously true. So 1 is my only true solution. Negative 5 was an extraneous solution, which happens from time to time. Okay, so like I said, check your answers. Plug them back in, make sure they actually work. So the next one, same idea for number 5. So radical's already isolated. I'm just going to simply square both sides, jump right into that step. So again, when you square the right-hand side, you got to FOIL this out. But on the right, or on the left-hand side, you would have negative 9x plus 28. Again, no more radicals since we squared it. And now negative x plus 4 times another negative x plus 4. What's that going to be? We get positive x squared, and then negative 4x, so minus 8x plus 16. Again, got a factor here. So move everything over to one side, add the 9x. Keep my x squared positive, so add 9x, subtract the 28. And then, so these all cancel. So we'd have x squared, that'd be a 1x, and then 16 minus 28 is negative 12 equals 0. Okay, so now factoring. What multiplies being negative 12 adds to be a positive 1. This is going to be positive 4, negative 3. And then solving it, again, we get two answers that you'd have to check. Negative 4 and then positive 3. But I'll let you guys know right now, I checked them already, and they actually do both work in this case, both negative 4 and positive 3. So if you plug them back in, so be careful when you plug that negative 4 back in, because when you plug it into like the right-hand side, for example, you already have a negative x. Okay, maybe I should just show that real quick. When you plug in negative 4, you're saying the square root of negative 9 times negative 4 plus 28 is going to equal negative 4 plus 4. So when you actually plug in negative 4, you got that negative 4, like I said. So this would be, what, 36 plus 28 equals, this would be positive 4 plus 4. So negative 4 makes that positive 4 plus 4. 36 and 28, let's see, 6 and 8 is 14, carry the 1. So that'd be 64. The square root of 64 equals 8. And that's a true statement. Okay, so negative 4 works. 3 also works too. Just be careful with the 3 because the right-hand side again would be negative 3 plus 4 when you plug in 3 for x, but they both work. Okay, so no extraneous solutions for that one. And number 6, again, you just want to jump right into squaring both sides of the equation, get rid of the radical. So the right-hand side, once again, you'd have to FOIL 2 minus square root x times another 2 minus square root x, and then just go through the same process from there. Okay, you actually do get a solution to this one. You only get one solution, however, so there's no factoring involved in this one. You get that x equals 16, but it doesn't actually work. Okay, so if you go through the whole process, you get an answer of x equals 16, but this does not actually work when you plug it back in, so there's actually no real solution to the problem. Okay, so if you want to kind of go through that one a little bit more, I'm just kind of running out of room here, but you guys can go through that one, try one on your own, see how it all works out. But moving on to the next page, we got more examples. Moving on. So at the top of the next page, so we have the x plus 5 is being raised to the 1/3 power. Well, if you recall, that's the same thing as the cubic root of x plus 5 equals 3. So again, rational exponents, if you have an exponent that's written as a fraction, it's the same thing as just the root. So you can just go in between those two forms, going from exponential to radical, radical into exponential. But now from here, again, technically my radical is isolated. I don't have anything outside of it, so I'm just going to go ahead and get rid of it. I cube both sides. So I'd have x plus 5 equals 27. Subtracting 5, x equals 22. Again, plug it back in, check it out, make sure it works. I'll let you guys know it all checks out. X does equal 22. The next one, again, this is the same thing as the square root. So 1/2 power is just square root of 2x plus 15, and this equals x. Okay, so radicals isolated, so I'm just going to go ahead and get rid of it. Square both sides, square root, so I'm going to square it. And again, once I see that x squared, now I got a factor. So bring everything over to one side. Again, I like to have a positive x squared, so I'm going to subtract the 2x, subtract the 15, and now it's equal to 0. Okay, so now factoring this out, this would factor into a -5 and a +3. And then solving it, we get two answers of x equals +5, x equals -3. I believe only one of them works, and looks like it's only going to be +5. -3 is an extraneous solution. And again, the quick way to check it, if you just plug -3 into like the right-hand side only, just the right-hand side, again, when we go to check, you're saying the square root of 2 times -3 plus 15 equals -3. A square root is not equal to a negative. That's not going to happen. We're asking for the principal root when it comes down to that. So that one does not work out. Okay, so only +5 is my true solution. For number 9, if you want to rewrite this in radical, this would be 3 times the square root of x plus 6. So notice the 3 is outside. Only the binomial x plus 6 is being raised to the 1/2 power, so that's the only part that's going to be underneath the square root. So first thing is isolate the radical, get the radical by itself, so move that 3 away, divide both sides by 3. So here's where we're at. And now, once the radical is isolated, now just get rid of it. So square root again, so I'm just going to square both sides. So x plus 6 equals 9. Subtracting 6, x equals 3. Check it, make sure it actually works, and I'm going to let you guys know right now, it does work. X equals 3. Okay. Now, basically, in these next examples, if you look at them, we have a radical on both sides of the equation. So now what the heck do we do? Well, if you have a radical on both sides of the equation, Okay, you can't really isolate the radical necessarily. So what I'm going to do is just get rid of it on both sides. They're both square roots, so just square both sides. So 4x plus 12 would just equal 6x. Okay, that's all you gotta do. So now from here solving, subtract 4x, so 12 equals 2x, and then divide both sides by 2, x equals 6. Again, check it, make sure it actually works. I'll let you guys know again, it actually works. So plug 6 back into both sides, and they do equal each other. The next one, so same idea, we got a radical on both sides, but we also have this 3 in front. Okay, there's no way, shape, or form that you can actually get rid of that 3. It's just going to have to stick where it's at. Okay, so if you think, well, maybe I just subtract 3 on both sides, or maybe I divide both sides by 3. Well, if you divide both sides by 3, you're just moving it to be underneath the other one. That's not really doing anything. Okay, so just leave the 3 where it's at. Just go ahead and jump right in. There's a radical on both sides. Just get rid of the radical, square both sides. Okay, so the left-hand side would be 7x plus 12. But when you square the right-hand side, you're squaring everything, the 3 and the square root. So you would now have 9 times 3x minus 2 with no more radical. Okay, so let me just pause here, make sure that makes sense. Again, squaring the whole entire right-hand side, you got to square everything, the 3 in the front and also the square root. So now what I'm probably going to do, I'll just go ahead and distribute the 9. So 7x plus 12, that'd be 27x minus 18. And now just solving for x. So if I subtract 7x on both sides, so if I subtract, that'd make that 20x. So 12 equals 20x minus 18. If I add 18, that would be 30 equals 20x. Divide both sides by 20. And we actually get a fraction for this one, x equals 3 over 2, or you can also say 1.5. Okay, again, plug it back in, both sides of the equation for x, make sure it works. I'll let you guys know right now it does work. And the last one, number 12, before we move on to the inequalities. For number 12, again, same idea as the previous one. You can't get rid of that 2 in the front, but you have a cubic root on both sides. So go ahead and cube both sides of the equation. You'd be left with x plus 6 is equal to, cube in the 2, you get 8. Cube in the cubic root, you get x minus 1. Okay? Again, I'll pause, make sure that makes sense. So it was 2 times the cubic root, now it's going to be 8 times just the radicand, the stuff that was underneath the cubic root. Distribute 8 to both terms, so you'd have x plus 6 equals 8x minus 8. And now solving for x, if I subtract 1x, that'd be 7x. So 6 equals 7x minus 8. Add 8 to both sides, 14 equals 7x. Divide both sides by 7, x equals 2. Again, plug it back in, make sure it actually works out. And I'll let you guys know again that x does equal 2. All right, so there's equations. Inequalities is basically the same thing. However, there's something a little extra we have to talk about. Okay, so I'll kind of walk you through as we go through these. So number 13. First thing again, isolate the radical. So I'm going to do that, move the 2 first. So we have the square root of x minus 3 is less than or equal to 3. Now, get rid of the radical, square both sides. So x minus 3 is less than or equal to 9. Add 3 to both sides, so x is less than or equal to 12. Okay, so think about what that solution means for a second. We're saying that x could be any number as long as it's less than or equal to 12. So even if you think about that on number line, right? So let's just say 12 is down here, closed circle, right? You'd be shading everything to the left. These are all the numbers that are less than positive 12. But this is not necessarily true. Okay, think about all those numbers that are less than 12. We're saying x could be anything. So that means that x could be 0 then, right? Because 0 is less than 12. X could then be negative 20. Again, because negative 20 is less than 12. But this is not necessarily true. So here's kind of the second part to this, okay? If you plug in, let's just say I plugged in, I don't know, what am I going to do? Negative 11 as an example, okay? Or even if I plug in 0, let me just stick with that. If I plug in 0 for x, we're saying the square root of 0 minus 3 plus 2 is less than or equal to 5. Well, 0 minus 3, that means I'm taking the square root of negative 3. And what's the square root of negative 3? Well, that's going to be imaginary, right? But graphically, when I actually graph out my solution set on a number line, there's no imaginary numbers here. We only have positive numbers, we got negative numbers, and we got 0. Okay, we got all those fractions and decimals in between. But there's no imaginary numbers. You cannot graph this out with this solution set. So like I said, there has to be some type of cutoff point. Where is the cutoff point going to be? Well, the question is basically this. So there's a second part to your solution. So this is true. X is going to be less than or equal to 12, but where is the cutoff point? Okay, where do I have to cut this off? Is it over here? Is it over here? All right. Where is it not going to be less than more values? So here's how you find that second part. You're going to take just your radical, just the radical. The key thing is this radical must stay greater than or equal to 0 at all times. You can only take the square root of numbers as long as it comes out to be bigger than or equal to 0. Okay, that's your stipulation. Kind of similar to when we were graphing these on the coordinate plane. When we were graphing square root functions, okay, very similar concept. Again, the radical must stay positive. It must be bigger than or equal to 0. It could be 0, but bigger than 0 is obviously more preferred. Okay, so if you just simply solve this for x, you square both sides, so x minus 3 is greater than or equal to 0 still. Add 3 to both sides. X also must stay bigger than or equal to 3. That's the cutoff point. So whatever x is going to be has to be in between these two values. Okay, so you can also write your answer more so as a compound statement. It's going to be less than or equal to 12, but it's also going to be bigger than or equal to 3. So as long as it stays in between those two, then we're fine. So I can't plug in like 2, for example. If you plug in 2 for x, well, 2 minus 3 is -1. Again, you have the square root of a negative number, so you can't do that. So anything outside of these two realms is not going to work. As long as this number is between 3 and 12, including 3, including 12, then we're all set. Okay, so similar idea for the next one. I'll go through and explain this one too. So for 14, isolate the radical, subtract 3 on both sides. So we have the square root of 5x minus 10. That'd be now 5, all right. Get rid of the radical, so square both sides, 5x minus 10. That's now 25, add 10, 35, divide by 5, and we get 7. And again, we run into this problem because not all values less than or equal to 7 are actually going to work in this problem. Okay, so where is our cutoff point? To find it, take just the radical, so just the square root of 5x minus 10, and again, the square root must stay positive. I don't know why I wrote a 10 again. Must stay greater than or equal to 0. Again, the radical itself could be 0, but greater than or equal to 0 is what we're aiming for. Okay, so now solving this for x, find the second part to my solution. Where's my cutoff point? Squaring both sides, 5x minus 10. That'd be 0. Add 10 to both sides, and then divide by 5. X also must be bigger than or equal to 2. So as long as x is in between these two values, as long as it's less than or equal to 7, but stays bigger than or equal to positive 2, then we're all set. Okay, we're good to go. Now for the next one. So first thing again, isolate the radical, move the 1. So we have the square root of 2x plus 2. This would be 4. Squaring both sides, 2x plus 2 is now 16, and then subtracting 2 is 14. Dividing by 2, we get 7. In this case, we don't have to worry about doing that second part. Reason why? Because it's greater. Okay, I don't ever have to worry about this becoming imaginary number because only numbers possibly less than or equal to 7 would give me a result of an imaginary solution. So if it's greater than or equal to, you don't have to worry about it. Okay, because I know if x is going to be greater than or equal to 7, I'm never going to dip back into the negatives. I'm never going to get a negative number underneath that radical. It's physically impossible. It's mathematically impossible. It's not going to work out. Okay, so this is my only stipulation. X just needs to be greater than or equal to 7. I don't have to do that second part because it's greater. Okay, only if it's less than do you have to do that second part. So these last two, you can already see this one says less than, this one says less than, but 17 works out a little differently. So I'll go through that one in detail. But for 16, similar idea. So 16, first isolate the radical. So add 2 to both sides. So square root of 4x minus 4 less than 6. Squaring both sides, 4x minus 4. That'd be 36. Add 4. That's 40. Divide by 4. X is less than 10. But where's the cutoff point? Again, not all values less than 10 are going to work for this problem. So I'm going to take my radical, just the square root part, Again, the key thing is that this must be greater than or equal to 0 at all times. Okay, so my cutoff point would be, so solving this now for x, squaring both sides, 4x minus 4, that's still 0, add 4 to both sides, dividing by 4, and we get 1. Okay, so as long as x is in this range, as long as x is less than 10, but bigger than or equal to positive 1, then we're all set. Then we're good to go. Okay, and the last one for number 17, for this one, so first isolating the radical, but to get rid of that negative 4, you'd have to divide it. And we know that when we divide by a negative, we also flip the sign. So now it's actually greater than, we have x plus 3, the square root of x plus 3 is now greater than positive 3, so I don't have to worry about doing that second part to my solution, okay, because now the sign is flipped. So now going through and solving, squaring both sides, x plus 3, that gives me 9, subtracting 3, we get 6. And that'd be it. So as long as it's greater than, you do not have to do that second part to your solution, only when it's less than. Okay, do you have to do the second part to find, again, the cutoff point to make sure you don't get imaginary numbers underneath your radical. But that is it for today, guys. Let us know if you have any questions as usual, but that's all we got for you. Thank you.